Welcome to this video. Hopefully you're doing well. So these are the basic things about our coordinate points that we need to know. Okay, first of all, we have a single dot, right? Whether it's a polar dot, which is in r comma theta form, or whether it's in x comma y form, right? It's just a dot sitting out in space on a grid. Okay, now of course if we had your vertical lines through there, it would be a rectangular grid, and if we had circular, right, if we had a bunch of circles, that would be a polar grid like we saw yesterday. Okay, so we're going to be converting from one grid form to another grid form basically. And we're going to use these relationships. Okay, so every x comma y, right, this is a rectangular coordinate. It has x and y's, like all of your things have done since algebra. And then your polars have r's and thetas. Well, if you're given a polar point, you use these two formulas to convert it into a rectangular. Okay, the x is always r cosine of theta, and the y is always your radius times the sine of theta. Okay, maybe those look familiar. If you've done anything with vectors, then those are the same exact formulas. Okay, likewise to find the radius, right? This is the radius of your circle, per se, that goes from the origin out to that point. Well, we're going to use the Pythagorean theorem in order to calculate that radius. And our angle is always going to be a tan ratio of the y over the x. Okay, and this comes from all the math that we've been doing for months now. So let's see how this looks. Make sure you have a calculator, and we'll talk about how to use it here in a second. So this says find the rectangular coordinates given the polar coordinates. That must mean that these are a polar coordinate. So this is your radius and your angle. Okay, your radius and your angle. So just for fun, let's take a second and see where on your polar grid that is going to be. So remember, on your polar grid, we have a pole in the center. And 0 degrees or 0 radians is still the positive x-axis. So we're going to measure our angle 3 pi over 4 from the positive x-axis. So that would be over here. 3 pi over 4 is a 135 degree angle, right? 135 degrees. So we're going to go out 4 units, or 4 dots, I'll make it 4 dots, from the origin. So 1, 2, 3, 4. This is the point that we are calling P, which is a radius of 4 at an angle of 3 pi over 4. So our job is to convert this into a y value, right? So we drop the vertical line, and that's going to be your y value, and our x value, which takes you back to the origin. So we're going to find these two lengths of basically a right triangle. Okay, so it says your radius is 4. That's the hypotenuse. And we know our angle is 3 pi over 4. Okay, so there were two formulas that we had just talked about. The x is always the radius times the cosine of your angle. So 4 times the cosine at 3 pi over 4. Okay, simple enough. Always radius times the cosine of your angle. And the y is the radius times the sine of your angle. Okay, that's how we start. The x is the radius times the cosine of your angle that you're given in your problem, right, with the point. And then the y is r, the radius, times the sine of that angle. Now, there are a couple of ways that we could approach this from here. You can go to your unit circle, and you can write down your values for sine and cosine. Okay, so let's do that, just to be efficient and exact. The cosine at 3 pi over 4. So from my unit circle, that's the x value. That's negative root 2 over 2. That's the cosine at 3 pi over 4, right? It's a fraction. It's not the cosine of that fraction. It's the actual fraction. It's the x coordinate at that point. And I'm going to multiply that by 4. Okay, likewise, I can find the y value at 3 pi over 4, which is positive root 2 over 2. And I'm going to multiply that by 4 also. Okay, so this is going to give us our exact value. Your paper says round, so we're going to plug this into our calculator in a minute. So 4 divided by 2, that's 2. So negative 2 root 2 is my x-coordinate. 4 divided by 2 is 2. And 4 divided by 2 is 2. So our x is negative 2 root 2, which makes sense. Hopefully it makes sense, right? Since our coordinate over here is in the second quadrant, our x value should always be negative in the second quadrant. And it turns out our math does that. And the y value should be positive, and it turns out our math does that also. Okay? So now let's do it a little bit simpler. Since that is an exact answer, it says round to some hundredths. So now we're going to go to your calculator. Okay, now if you're using a fancy Inspire, you need to make sure that it is in radian mode. Okay, this angle is a radian angle. So if you try typing this in, if your calculator is in degree mode, it's going to give you an answer, just not the right answer. So make sure that your calculator is in radian mode. Okay, here are your answers when you put it into your calculator. Okay, making sure your calculator is in radian mode, because this is a radian angle measure. 3 pi over 4 is a radian angle, because it's not a degree. Okay, let's jump over and look at number 2. So here's our next one. -1 is the radius, and 2.03 is the angle in radians. Right? We know it's in radians because it doesn't have a degree on it. Okay, so from a previous, actually I didn't make a video. From our previous lesson, 2.03 radians is about right in here maybe. Okay, so this would be the 2.03 radians. Now -1 means we're going away from the origin, right? We're walking backwards. So that's going to be our coordinate that we're trying to find. This is a 4th quadrant point. 4th quadrant point. So let's see if that plays out with our math. Okay, so we're just going to plug it right into your formula. This is -1 times the cosine at 2.03 radians, and -1 times the sine of 2.03 radians. So make sure you're in radian mode, and let's see what you get when you plug this into your calculator. So this is what my calculator gives me, a positive x value, which is exactly what we expected from our dots, right, from our coordinate, and a negative y value. In the 4th quadrant, x is always positive and y is always negative. Good. I'm glad that our calculator bears, right, it's validating our point that we do from the graph. Okay, so if you have an r theta, that's how you get to an xy, right, a rectangular point. But what if we go the other way? Well, once again, the radius is found by doing the Pythagorean theorem, and the angle is the inverse tan. Sorry, this is another way to write inverse tan or arctan. Okay, so I know our calculator doesn't have arctan, it has tan inverse. So that's what we're going to do. All right, so let's go back to our brain. 3, -3. 3, -3 is in the 4th quadrant, right? It's a +3 on the x and a -3 in the y. So here's our coordinate point, 3, 3. 3 to the right and 3 down. So it's a 4th quadrant. So we're going to find the radius. So you go back to your origin. That's the radius that we're looking for, right? We're making a triangle or a circle. So from the origin to that point, that's your radial length. And we're also going to find this angle, always found between the x-axis and your radius. Okay, so basically we have a right triangle, right? We can make our triangle that looks like this, where the radius is your hypotenuse. So that's what we're finding. Radius equals the square root of x squared plus y squared. Okay, and you can put that right into your calculator, or maybe not. 3 squared is 9, negative 3 squared is 9. 9 plus 9 is 18. So this radius, the length of this hypotenuse, is the square root of 18. Okay, you can leave it just like that. There's no need to decimalize that. 4 point whatever. Root 18 is a perfectly awesome answer. Now for the angle, right? What is the angle for our formula? So the angle is always the inverse tan of the y over the x. Inverse tan of y over x. Make sure that you change your calculator back to degrees, or this will give you a radian answer, which might not be understandable to you. So if you do have it in degrees, it tells you this angle is negative 45 degrees. Okay, does that look like a negative 45 degree angle? Right, sure. Negative angles start at your positive x-axis and come down. I would say that a negative 45 degree angle would be perfectly okay. Now, if you're a purist, then you probably want to change it to a positive angle, which is this one that goes all the way around. Okay, so that one is 360, your entire circle, minus 45, which would be 315 degrees. So for a fourth quadrant and for a fourth quadrant angle only, you can represent the angle in a couple of ways. You can write it as the one from your calculator, which will be negative. By the way, your calculator will tell you that the angle is negative. Or you could write it using the positive angle, which would be 315 degrees. Okay, so this is your choice. This is up to you on how you write it. Now, if it were a multiple choice test and negative 45 weren't available, you would have to know to change your negative 45 to its 315 degree equivalent. Okay, but if you're just doing work and you're doing work, then 315 is fine with me. Okay, perfect. Let's try again with this coordinate, negative 4 roots of 3. So in what quadrant do we have negative 4 and negative 4 roots of 3? Well, negative 4 goes left 4 units, and negative 4 roots of 3 goes down. So this is going to be a third quadrant angle, or a third quadrant point. Okay, our point is here in the third quadrant. So once again, you take your origin and you draw a line to that point. That's going to be your radius. And when we get around to it, our angle is going to be this one, always formed with the x-axis. That's the angle that we're going to calculate. Okay, let's see how well your calculator skills are. Negative 4 squared plus negative 4 root 3 squared. Okay, what does your calculator give you? You should be getting 8 when you put this into your calculator correctly. Now let's talk about our angle. The angle is the inverse tan of negative 4 roots of 3 over negative 4. Okay, so hit control divide. When we do this, when you hit control divide, you're going to get a fraction so that you're able to put negative 4 root 3 and then scroll down and put negative 4 in there. 60 should be your answer. Now remember what you just found. You found the angle between the radius and the x-axis. But our answer starts at the positive x. So we want the whole entire thing all the way around. So 60 is not our answer. Our answer is 60 plus 180, right? Because it's 180 to get to your x, the top part of your circle there is 180 degrees, plus 60. So your answer in radius is 8 as the radius and 240 degrees as your angle. Okay, so depending on where your point is in the third quadrant, you have to add 180 to your calculated angle. If it's in the second quadrant, you're going to subtract 180 from your calculated angle. Okay? It's not always the thing that you calculate is your answer. Sometimes you have to do some interpretation and know what it is that you are actually looking for. Okay, so some more practice. Here we have an r and a theta. Right? This is radius and theta to convert to rectangular. Okay, now let me give you a calculator tip. When you're doing these, you can always have it in radian mode, especially if you're using a TI Nspire. All you have to do in the calculator is put a degree symbol on your answer. And it will know, the calculator will know that you are asking for a degree angle, not a radian angle. And that turns out to be your answer when you plug it into the calculator. So 50 degrees is in the first quadrant, so we're expecting both of these to be positive, and they are. Okay, number 6, -5 and 3 pi over 8. So we have -5 times the cosine at 3 pi over 8, and we have -5 times the sine of 3 pi over 8. Okay, so if you're already in radian mode, then your calculator can take this straight away. And here are your decimals for this one, right? We're plugging it right into our calculator, and you're using the calculator to do all of the work for us. Okay, likewise for our last one, here's how you do it. Okay, and there are the answers for 7,100. Okay, now we're going to go the opposite way, and we're just going to skip number 8 and do 9 and 10 because they are much more interesting. So number 9 is -5, +9, which is a coordinate in the second quadrant. Okay, second quadrant. So we're going to find the radius here and the angle. Okay, the same way we did up above. So I'm going to pause and do all the work, and I'll be right back. So here's what we've calculated so far. Your radius is 10.296, and the angle we calculated, this angle here in the second quadrant, is -60.9. Okay, that might not make any sense because this is definitely not a negative angle. But in the second quadrant, all tangent is negative. Tangent is negative in the second quadrant. Okay, automatically, that's what the tangent is. So we need to interpret this and subtract it from 180 because we want the angle from the positive x-axis anyway. So 180 minus 60.9 is 119.1. That is the angle that we're looking for. So our answer is the radius 10.296 and the angle 119.1 degrees. That is your final answer for this problem. Okay, so when we're not in the first quadrant, things need to be adjusted. So number 10 is a fourth quadrant, right? So it's 7 in the x and -8 in the y. So that is our point that we are looking for. So here is your radius that we're going to find, and then our angle is right there. Okay, so in the fourth quadrant, our calculator is going to tell us this is going to be negative, which is okay for this problem. So pause, work it out, and I'll be right back with the solution. So these are my values. I have a radius of 10.63 and an angle of -48.8 degrees, which is okay to have that as my answer because it is a fourth quadrant point. Okay, I could also do 360 minus 48.8 and that would give me a 311.2 degree angle if you're so inclined to do that. If not, a negative angle is fine. Okay, so be aware of your quadrant, because in the quadrant your angles have different things, right? Where don't get your right answer if you do it with a different quadrant. So just be aware of that when you're finding these angles, when you're converting from a rectangle to a polar. All right, have a great day.